The following tutorial is meant to show you how to solve a problem like the pre-lab question number 3 in the specific heat capacity lab. When conducting a problem like this, it's important to remember that the energy lost by the metal will be equal to the energy gained by the water. We don't actually have to calculate the energy in order to solve this problem. As with all problems, we want to list out all of the information that we know before we begin plugging in numbers into an equation. We know that the mass of iron is 21.5 grams. We also know that the specific heat of iron is 0.449 joules per gram degrees Celsius. We're looking for the temperature change, and in order to do this, we need to know the final temperature. That is going to be our unknown variable in our equation. So the change in temperature for the iron will be its starting temperature of 100.0 degrees Celsius minus the final temperature at equilibrium. We also know the value of the mass of water, and that was listed at 132.0 grams. The specific heat capacity of water is always 4.184 joules per gram degrees Celsius. Again, we're looking for that final temperature, and in this case, when we write our temperature change, we're going to write the final temperature first, and then subtract out the initial temperature. The reason we're doing this is we want to keep the temperature changes positive on both sides of the equation. The next step then will be to write out, since we know Q of the metal is equal to the Q of the water, we're going to remember that Q is equal to mc delta T, and we're going to set the equations equal to each other. I'm going to take a little time right now to write down all of the variables that we know in the order that we know them in. So you know the mass of metal times its specific heat minus the change in temperature is going to equal the mass of water times its specific heat times the change in temperature. And then we're going to do a little bit of distributive property and undo all of that. And now we're going to have to rework that to isolate for TF. So we're going to go ahead and add the 9.6535 temperature final to both sides. And then we'll add the 11,045.76 to both sides. Doing some calculator work, we get 12,011.11 equals 561.9415 temperature final. In order to isolate temperature final, it's our last step. We're going to divide both sides by 561.9415. Again, a little bit of calculator work. And we come up with an answer of 21.3743 degrees Celsius, and that's our final temperature. But looking back in the original problem, looking for the least amount of sig figs, we had 3 there, 3 in the specific heat of iron, 3 in the initial temperature of water, and so we need to round our final answer to 3 sig figs. So 21.4 degrees Celsius should be equal to our final temperature. One thing we can do to double check this is plug that number back in and make sure that our Q values are equal after we do some additional math.